do have
projected. Gotta do your job, Jeff. You can't look at the other shit. Okay. It's gonna be exciting. All right, guys. So yes, I have a feeling, especially because of the amount of homework that I have not gotten, that you're all pretty much still in chapter 9. So tell me now if you have any questions from chapter 9 before I jump back into chapter 10.
Yeah, I have a question about.
Yeah, good.
Sorry, about section 9.3.
9.3. Oh, I got a chat too. I haven't opened my chat. All right, I'll do that next. All right, so let's see, where are we at 9.3?
Questions 38 through 44. Specifically, I'm talking about question 42.
Oh yeah.
So I rewrote it, and I don't know, because it says with an exponent no higher than 1. It was just kind of a general question about how exponents work, I guess, with trig functions, because my end answer is a fraction with a bunch of different trig functions added together, and then I also got cosine 4x times cosine 2x. And so I don't know, because that's 2 cosines multiplied together. Does that count as like an exponent of 2, or is it still an exponent of 1?
Still an exponent of 1.
All right, got it. Yeah, so that's a final answer then?
Yes, if that's where you
got.
And it seemed like that could happen. Yeah. And of course, the formula you're using is what they call the power reduction. I think that. Mm-hmm. Yeah, power reducing formula, which is sort of like a halfway point between the half angle one that we have to memorize and the double angle formula. These are just one step away from the double angle formula, these guys.
Yeah.
And anybody who's just joining, you can see why they call it power reducing, because it takes it from a second degree to a first. But if you do have, where were they? Oh yeah, here. If you do have a fourth power, I'm pretty sure we did at least part of a problem. Oh shit, I wouldn't even share my screen there, was I? Dadgummit, Jeff. All right, so here are the power reducing. Where'd you go? Did I pass it? No, you didn't, Jeff. You didn't get there yet. An instructor's slow descent into madness. All right, so here's the power reducing, because we take it from a second degree to a first degree. The trade-off is we make the angle double. And hopefully you guys are familiar enough with the double angle formulas to see that these two especially are just one step away from the cosine double angle formula. And this is one step away from the half angle formula that we developed. Okay. So if you have like a sine to the fourth, you have to write that. So for example, if I had to do number 40, you would have to write that as sine squared of 8x squared. Then you apply the formula, the power reducing formula, you apply it to the inside, have all this shit, and then you have to square that. And when you square it, you're going to get some other things that have squared powers. So you have to use the power reducing again. So it's a semi-long problem, but it really shouldn't be a difficult problem. All right. Let me see. Sure. All right. Let's do one as an example, and then I'll catch up on the other questions I got here. I probably didn't assign this one, did I? So let's do this one. All right. Let me see. Let me do this for myself. Oh, can I do this for myself? That's a good question, Jeff. I don't think you can. Dadgummit. All right. We'll do it live. Do it live. So sine squared theta. Now, and again, this really just comes from cosine squared theta. Let me get out of there. I got to start here. Cosine squared theta minus sine squared theta equals cosine 2 theta. So then I can do 1 minus 2 sine squared theta equals cosine 2 theta. That's another one. Is everybody with me, sort of? Remember the cosine double angle has 3 options, right? because I can rewrite cosine squared as 1 minus sine squared. So I get a couple of sine squareds then. So if I solve this for sine squared, I'll get, you can do it, Jeff, 1 minus cosine 2 theta over 2. Yes, okay, good. All right. I don't have this memorized perfectly, so let me get rid of this. Try it again. Let me stop for a minute. Everybody kind of with me? So what I just did, you wouldn't have to do. You could just look it up, right? The power reducing formula. I just can't scroll right now, so I couldn't look it up. So theta for me now is 8x. So why did I have to put that square out there? Because there's a fourth power, and the rule only applies to squares. Is everybody with me? Right? So now the rule directly applies to this. So 1 minus cosine of twice the angle divided by 2, and then I have to square that. So what I always do is take the 1/4, square the 2, get that done, and then I got to square this. I got less fractions to carry around with me. So I feel like we've done one of these. 1 minus 2 of these plus cosine squared. All right, let me stop for a minute. Let me know the minute I lose you. Oh, I don't know. Oh, all right. Nothing. So when I write something like sine of 8x, there ain't shit that I could attack this with from outside that would do anything to this. Is everybody with me? I could use identities to double the angle like this one does, but I can't square this and suddenly that changes this in here. There's no way in hell. I really need you to understand that. So when I am squaring this, nowhere am I squaring x. Nowhere. I don't have an x in here. I have a cosine of shit. So when I square cosine of shit, I got cosine squared of shit, right? Or stuff, if you prefer that word. Does that make sense? Let me see. So you just multiply by 2. All right, and I really want you guys to understand, here is the rule that we have proven. We proved that rule together. We proved it. What does that rule say? If I have sine squared of something, that's 1 minus cosine of twice that something over 2. Yes? So trust me, I understand that we start to lose touch with where things came from because there's a lot of things that came from a lot of places. But this is why number one, you need to understand it when we develop a formula, but then you need to understand how to correctly use the formula. What does the formula say? Okay, I like it. I like it. This is good. And again, don't take my tone. Hopefully my tone isn't coming off any other way than I understand the struggle, right? I do. So you got to remind yourself about what this means and what changes what. So the angle doubles according to this identity, which we proved. So now I just do what it tells me to because I proved it, so I trust it. Now, I'm not done yet because I got a squared thing there. Everything else can basically stay the same. And now that I know this rule, this cosine squared is just going to have a plus there. That's the difference. So this will be 1 plus cosine of twice that angle over 2. Get in there. Shaboop. And now I'm done. Yay. Because now I have everything in terms of first powers. Is that right? And this is new. The algebra is old. The trig function and the identities are new, but you just have to know how to read them. There's a set of instructions on what to do, right? Is that better? Is that all right out there? I want to catch up with the other questions. All right. So I have a question from section 9.2. I'm going to clear all this away. Anybody still need that up there? You guys okay with me clearing that away? Brain, just keep on math. My brain keeps going to, how's Florida going? Stop it. Clear, go there. 9.2, okay, 9.2. Number 54, go to 9.2, there you go. Oh yeah, all right, so two things. This is like a bonus. That doesn't mean I'm not going to talk about it. 54, this guy, right? This guy here, person out there. This feels like I've talked about this before, maybe not, but I want to point out a couple of things. Here is the tangent sum that you don't have to memorize, but you can look it up, right? So that's the first thing I would do is put that in there. And this doesn't look like it's very far away from the answer. It's interesting. Let me show you something. Let me see. All right, darn it, where is it? There it is. Okay. Oh my gosh, so much shit. Here we go. There it is. All right, here's the tangent there. Do you see how that looks a lot like the form of the answer? That one doesn't look like it's very difficult then. I don't mean to make you feel bad if you had trouble with it. From what it looks like, I don't know, have you tried using this to rewrite that first numerator? Person out there. Person out there. Oh, you disproved it. Oh, okay, cool. Yeah, no. It looks like it's gonna go that way, but it looks like maybe it's missing something here. Actually, I'm curious now. All right, let's see. Let's do this one, guys. Shit, I picked the wrong one. Okay, there. So tangent of x plus y. All right, Jeff, this is going to be scary. I think it's tangent x tangent y. Can somebody double check me on this? Jeebus. Get out of there. Come on. Tangent x tangent y over 1 minus tangent. No, it's tangent x plus tangent y, right? That's what I'm missing. Okay, thank you. I think somebody's chatting that at me right now. Maybe not. No, nobody helped me at all except for Jason. I appreciate that, Jason. Oh, I got to spotlight me. All right, there we go. It's all about me. Okay. So if you replace this, now watch what I'm going to do. Watch what I'm understanding what I'm about to do. I'm about to replace that numerator with a whole fraction. So I'm going to write it like this first. Oh, I see. They screwed up. I wonder if that's just a typo, but okay, you're right. I think if that was a Y there, this would have worked beautifully. Is that what you noticed out there? Did you notice that? I didn't even notice it.
Yeah, that's what I got.
You're right.
Cubed
You're right. I'm sorry. It's sort of like watching the news when they're interviewing somebody from across the world and there's this huge delay. All right, sorry. Yeah, if there was a Y there, I think it would work. But there's an X there. Ain't no way in hell it's going to work. I agree with you. Beautiful. All right, so that's it for that. Okay. Let me see. Somebody else had a question. Oh, wait, is that the same one? I got another question in here, and then I got a question in 9.3. So let's look at this one. Chapter, section 9.2, number 10. Oh, okay. Yeah, okay. This is all about sum and difference identities, right? So this is a sum. And these are two that we've done a lot. So by this point, you should have this memorized. So what is sine of A plus B?
Sine A cosine B plus sine B cosine A.
Kick ass. So that's all you do. That's A, that's B. Rewrite it. Oh shit, I didn't mean to cross that out. Poor little dude. Oh crappity dude. All right, you know, is that all right? That's all you got to do? That's all you got to do. A is 11, where do you go? A is X, so put an X in for A, and B is 11 pi over 6. And then you can actually calculate those then. Is that all right out there? Person out there, give me some idea. All right, you don't want to tell me. Okay, so that's all I'll do. Then the other question I had, oh, there you are. Do you see how this is in terms of sine and cosine? So you'll be done once you plug it in. Yeah, there you go, done. So the other question was number 12 and 9.3. Cooperate with me. All right. Hello. Okay. What's going on with everything? 12. Oh, yeah. All right. This is one of our favorites. This is like if I was a rock band, you guys would say, do number 12 again. Yeah, I hope you don't take that wrong, but we've done this one several times. The big thing to realize is, here's the thing. I'll do the same thing I did the other night. So 2 sine theta cosine theta. Does anyone know that what that's the, how I can rewrite that? Beautifully compact.
Sine 2 theta.
Yes, that's the double angle formula for sine. I love it. So if I multiply both sides by 2, 4 sine theta cosine theta is 2 sine 2 theta. And do you see how that's, you know what theta is? So you just plug it in. Is that cool out there? You guys all right with me? Are you starting to see how the identities, what's the important thing about the identities? Which one, and then what's theta? Because they tell you how to rewrite things, and sometimes theta changes. It doubles, it gets cut in half, you square the trig thing. So you figure out what theta is, and sometimes you have to figure out what A and B are for some and different stuff. Are you guys with me? Right? Once you get those angles figured out, you put it into the form of the rewritten, what the identity says, and then you do it, and then you just calculate it. You're welcome. You're welcome. Okay. So this is good. I'm starting to get a better feel for exactly what it is that's troubling some of you guys. Doesn't cosine get multiplied by 2? Wait, wait. Sorry. I had somebody just, all right. I got a good question. All right. All right, real quick. What is 3 times 5?
$15.
Hello. Good. Thank you. What is twice that? Is twice 3 times 5? Is that 6 times 10? Do they both get a 2? No, the whole thing already got a 2. So it'd just be 30, not 60, right? So when I double this, and now there's a 4, it isn't sine that's getting this. It's this whole thing that's getting that. Yeah, it's all connected by multiplication. All right. And private chatter, don't take that wrong. Just really, really realize that, because that kind of thing's going to happen a lot. Okay, I like it. So the quiz is only 9-1 through 9-4. That's right. And I said it was Monday, right? I got to write a note for myself. You guys had a possible thing there. You could have said, no, I think you said it was Wednesday, John. But I appreciate your honesty. Yeah, it's Monday, and the quiz will be 9-1 through 9-4, because I didn't feel like you would have enough time with 9.5, possibly, considering where most of you guys are with the homework. Okay. Anything else, guys? I think I am caught up with questions. Is there anything else? Okay. What I want to do is first remind everybody what we proved yesterday and the day before that, right? The law of sines and the law of cosines. And then we want to do several examples of those. And then we'll probably call it an evening, because at that point, the little thing in the back of my brain saying Trump might have already won is going to just overwhelm me. All right. I'm going to go a little bit into a depression if I don't check. All right, here we go. Let me stop sharing. If you want Trump to win, I don't want to hear it. Keep it to yourself. I don't give a shit about not showing my political biases anymore. I don't. All right. Jeff has lost it. All right, let's see. So, don't worry. So, my point earlier was not that you have to keep in your head, oh, crappity doodah. What did you do with this, Jeff? Chumbawamba. Yeah, you can do it, buddy. Yeah. I don't know why it's being so weird. All right. This thing is also weird. All right. All right, Jeff, just leave it. So law of sines is really, really simple. Let me write it. I think this is the way we wrote it the first time. And at this point, you certainly should know what the capital letters denote. What do the capital letters denote? Even if you don't know, you should be able to surmise, considering where they are. What do the capital letters mean?
The angles.
Angles, and the lowercase letters are the sides. I love it. So the book might write this with gammas and bullshit, right? So that's the law of sines. You can only use the law of sines when you can make a complete ratio. Anything that you can't use the law of sines for, the law of cosines will work if the triangle is solvable, right? They could give you one that's not solvable. So the law of cosines, this is the law of sines. The law of cosines, maybe we can call it loco. This will be loci. Why not? There's three ways to write it, and they're basically all the same thing. C squared equals A squared plus B squared. Ah, it's Pythagorean. Nope. Let's see if you guys get the main. So what would it look like for solve for B squared?
B squared
Yeah, I'm sorry. B squared
equals C squared minus A squared plus.
Oh, I see. I see what you're doing. No. So let me write this out. You ready? I mean, you're right. You're right to a point, but it's A squared plus C squared minus 2AC cosine B. If it's not a right triangle, it doesn't matter what side we call A, B, or C. What do we always call C in a right triangle? C is always the what?
C is always the hypotenuse.
Yeah, in a not right triangle, which side C? Whatever the hell side you want it to be C. Who gives a shit, right? That is why there are three ways to write this, because there's three sides to call whatever the hell you want to. It's kind of dumb. It kind of is. There isn't really three formulas is what I'm trying to say. But we might as well, just in case you run across all of these. So it's going to be, so what's the rule? It's going to be the other two sides added together, squared, minus twice those two sides multiplied, times the cosine of that angle.
So when you solve for b there, are you missing a lowercase b with the cosine? Because it's b squared equals a squared plus c squared.
I see
minus-
what I did.
Yeah,
No. I'm not missing a B. What am I missing?
a c.
Yeah, and of course I took the cosine to be.
Oh, okay. Got it.
Sorry, that's my bad. But do you see how it goes? A, B, A, B. C, C. A, C, A, C. B, B. All right. So you really only have to memorize one. And I really understand whoever was trying to tell me what goes here, I understand what you were thinking. You were thinking normal, right triangle, solve, because C is the hypotenuse. No, now it doesn't matter. Okay. So let's try, this is the new stuff to us. We've done some problems with this. We haven't done anything with this because that's the last thing I did was show you where this comes from last time. So let's do some work with this. So here's kind of a neat triangle we can solve. I'm not your triangle to solve. No. Here's a cool triangle we can solve. And I've got to be careful. Let me see if you guys understand why I have to be careful. I'm going to identify all three sides. If I don't do it right, so if I say this is 3 and this is 4, can this be 7? At least not the way that I, but what do you guys think? If one side is 3, oh no, don't. Okay, all right, don't. I appreciate it, but don't private message me anything about the election, all right? Or my brain is just gonna go. Does anybody not see why this side cannot be 7?
Isn't
Maybe
that
I'm-
only true for a right angle?
No. Well, let's see. Let's try to make it 7. Let's see what happens. This could be interesting. So I can call these anything I want to. Not surprisingly, I sort of always made this I made C the biggest side, just because. Now this is neat. Why could I not use law of sines for this triangle, to solve this triangle? And what does it mean to solve the triangle? Let's start there first. What would it mean to solve this triangle? What do I need to figure out? Sorry.
Find all the angles.
The angles. I know all the sides. I just need all the angles. Why could I not use law of sines?
Because you don't have one complete set.
Yeah, I need an angle and its associated side to make a complete ratio. Exactly. So until today, you really didn't have an example of what I meant by you can't use law of sines if you can't make a complete ratio. Well, I can't make a complete ratio here. I don't have any associated angles. But I can. So the way I've identified these, C is right there, A is right there, B is right there. Is everybody cool with that? That's the only way it could be, because C, A, B. So let's use, I can figure out what angle C is using this. Do you guys see that? Yes, no, maybe? So if I plug stuff in, 7 squared equals, where'd it go? 3 squared plus 4 squared. Yeah, maybe I'm wrong. Maybe I'm forgetting what can happen here. 2 times 3 times 4 cosine C. So the only thing I don't know is angle C. Is anybody not with me right now?
So basically all the variables represent the sides except for what's with cosine.
Yes.
Okay.
So it's tradition or convention to use lowercase letters for sides, uppercase letters for angles. And if it's inside a trig function, it really does have to be an angle. You got to be looking, if it's not inside a trig function, it could be an angle, but lowercase letters are understood to represent sides. And all right, is everybody with me on that so far? Okay. And so now I can just solve for cosine C, and then I can take an inverse cosine. Let's see if we can do this. So it'll be 49 equals 9 plus 16 minus 24 cosine C. So it'll be 24 divided by negative 24. Yeah, there we go. Now you're starting to see what the problem is, maybe. Cosine C would have to be negative 1. I'm going to let you guys catch up to me. Is that all right? I mean, once you plug this shit in, it's algebra. Collect your like terms, get everything, get cosine C by itself, and then you can take an inverse cosine of both sides. But what is the inverse cosine of negative 1? Where is cosine negative 1?
180 pi.
And why is that a problem for the triangle?
Because the angle has to be less than 180.
Yeah. So think about it. The only way that one angle and the other angle and then this side is 7 is if these are flat, because then they would make 7. That's why this can't be 7. It's got to be less than 7. Do you guys understand? Because the only way to have a 3 and a 4 and then to have the side be 7 is if they're straight, and then it's not a triangle. Does it make any sense?
Yes, that makes sense.
Thank you. So let's try another problem that'll actually work. So let me recreate this guy. So if I make this, sure, 3 and 4, then this could be 5. Yay. Now that's what's funny here is, let's see if anybody knows, well, let's see what happens. I'm sure somebody out there understands something about the triangle I just created. My creation. Let's verify that. I don't know if anybody does actually, but go ahead and try to set up the equation. Do it. So this is little c, this is little b, and this is little little a. So try to set up the equation and you'll get something very interesting. Let me catch up to you here. So c squared equals a squared plus b squared minus 2ab cosine c. Well, what happens here?
Turns to 0.
0 equals, who gives a shit, divide by that. So of course c is what? When is cosine 0?
90.
90 degrees. So what kind of triangle is this really?
A right triangle.
Right triangle, and hopefully somebody remembered 3, 4, 5 triangle is a right triangle. That's the most basic one. 5, 12, 13 is also a right triangle. All right. And then, even it's pretending like this is not a right triangle. If I keep going, I can figure out all I need is one more angle, right? So now I know C is 90, and I'll pretend like I'm completely oblivious and I don't even think this is a right triangle. How do I get angle A? Well, even that doesn't help you, Jeff. That's true. How do we get angle A? Well, I want to use the one that has an A in it. So it's got to be the one that's this, solve for A. That thing really messes me up. Look at cosine A. Are you going with, if I want to get angle A, then it's got to be the one solved for A, because that's when this angle is going to be. So start and end with the same letter. And in the middle is the other letters. I like
Once
it.
you get one angle, can't you use the law of cosine, law of sine?
You totally could. Excellent. Why might I not want to do that? Because cosines, what's the range of inverse cosine? Anybody? Range of inverse cosine?
0 to pi.
0 to pi. So if an angle was supposed to be larger than 90, inverse cosine will tell it to me directly. Inverse sine will give me a reference angle that I have to realize is a reference angle. Are you guys with me? Maybe. To be honest, most of the time that's not really going to happen that way. But so technically you're right. You have a complete ratio you could make. You can use law of sines. I'm telling you not to right now. Ha. Okay, so if I plug in what I know A is 3, so 3 squared. I know B is 4. I know C is 5. So then I can figure out what angle A is by doing this business. So what is this? This will be 41, subtract 41 is 32, right? Divided by, twice 16. Is that right? Did I do that
What?
right?
No, the 2 times 4 times 5, right?
What am I doing?
Yeah.
Thank you so much. I got way too hung up on the squares. Let's try that again, Jeff. -7, it's -32, yeah. Divided by -8 times 5 equals cosine A. And the reason I do that is because that goes in there. So that becomes 4. So 4/5, which, why? Now what? Let me stop for a minute. Do you guys see? Do you guys see how we just basically, and here's another reason why I didn't want to use law of sines. Do you guys see how I've just recreated the definition of cosine for a right triangle, right? What's the cosine of A? If that's the 90-degree angle, the cosine of A would be this over 5. If you kind of move your head, all right. Maybe you didn't have to know that to get here. So now you just have to do the inverse cosine of 4/5. And of course, why do I definitely not have to do law of sines or cosines for the last one? Because now I got 2 freaking angles. I could figure out the third one, right? So whatever the hell that is, I just see what's left over for B. All right. So yeah, throw that in the calculator. I'm not interested anymore. What other situation? So side. If you're a fan of thinking it like this, I kind of like these because, of course, the ASS is the law of sines one that makes us do more work. So that's ASS is a perfect way. So it'd be angle, side. That one sucks. Side is the one we just did. That's the one that law of cosines has to work on only. It can't be law of sines. What other situation would I need to use law of cosines? Let me say I know this angle. Let's say I know angle A. Let's say I know angle A is what, Jeff, is 33 degrees. What side can I not know if I don't want to be able to use law of sines? If I want to create a problem for you where you can't use law of sines, what side can I not know?
Side A.
Side A, because then if I did know A, I could make a ratio, I could use law of sines. So I don't want to give that to you. So I got to tell you side B, let's say side B is 6, and let's say side C is 9. I don't know why I had so much trouble with that. So this is obviously side, angle, side. So that's another one that law of cosines works for. So using law of cosines, let me write them all up here again. What could I use what I know. What could I figure out right now? Oh my God, I was on like, okay, everything was good. I went on cruise control there. Thankfully, okay. The only angle I know is which one? What's the only angle I know?
Angle A.
So which one of these three, the first, second, or third, do you think I should use?
The first one.
The first one, because that's the one I know B and C, and I know angle A, and the only thing I don't know is little a. So then I could use it. So go ahead and do it. I'm going to sit here or stand here, I guess, and wait. Just throw in everything you know in the right place, and everything will be fine. All right. So it'll be b squared plus c squared. It'll be 6 squared plus 9 squared. All right, Jeff, let's see if you can do this right this time. Minus twice 6 times 9 times cosine of 33 for Larry Bird. This is where people do extraordinarily silly things. What do I mean by that? This is where I'll have people do stuff like this. They'll get 117 there, right? 117, I think, minus, oh, what the hell is that going to be? I don't have a clue. 108, is that what that is? Maybe. Yes, okay. And then I'll get this. Can somebody please, if you wrote this down, don't say anything, but somebody help me out. Does that look good? Does that look good?
No.
Hell no is the correct answer. The correct answer, what I was looking for was hell no. Shit no. These aren't like terms. What the shit, man? So I walk a fine line with you guys because you need to know your algebra, but I don't want to make you feel like shit if you don't. But you need to know your algebra. So it's a fun one. So now you just throw this in a little calculator and take a square root. So it's a equals square root of all this shit. So I would just put all this shit in ye old calculator. Make sure you're in degrees. How's everybody doing out there? You guys all right? 2020 okay? Let's all hope. Let's all pray. Please let me be happy tomorrow. All right, has anybody got something yet?
I got 5.14.
Yeah, that's what I got. Why does that make sense? Can somebody reply to me in terms of mouth size? Mouth size. Why does that make sense? We got 5.14. Nobody wants to say, okay. This is probably going to be the smallest angle in the triangle because it makes 180 total. So that makes sense that that's the smallest side. Now I'm going to predict that angle B is just going to be a little bit bigger than that because side B is just a little bit bigger than that. Are you guys with me? It's the whole stick in the mouth thing that I was talking about. I have no idea how you guys feel about that analogy. And it's so many things, I don't care because it works for me. So if you like a different thing, use a different thing. So how do I figure out what do I still need? I need angle B now, right? So if you wanted to, you could use this guy, or as somebody else just said, you certainly could use law of sines, right? Let's try to use law of sines just to kind of review that real quick. How can I use law of sines to figure out angle B? Ouch. Is anybody out there with me? What ratio can I fully create for law of
The
sines?
sine of 33 degrees over 5.14.
Thank you. And then I can do the sine of B over 6. So this isn't too bad. Multiply by 6, take an inverse sine. So I would throw all this shit here into the calculator. I don't know why I put you in parentheses. Let's not do that. Is that right? Multiply by 6 and then take an inverse sine. So inverse sine of all shit. That's how we got. Okay. Inverse sine of all that shit. Oh shit. Oh, I see. What am I doing? There we go. Anybody get an answer?
I got a
Have-
domain error. Did I just type it in wrong?
You did. Make sure you're in degrees,
Oh, okay. Thank you.
not radians. Yeah. Sine of 30 is 1/2. Half of 6 is 3. 3/5 is less than 1. So this should have an answer. If this inside was bigger than 1 or smaller than -1, no answer possible, right? Because that goes outside of what sine can do. But this inside looks to be less than 1. So I should get an answer.
So I got 2.68.
A rut-row.
Nope. I'm off again.
Yeah.
Shit. I'm doing
I
something
got
off.
39.48. If you
Yes.
continue on, it's longer.
39.48, that's fine. A couple places is fine. And of course, I don't have to do anything anymore now. I've got angle A is 33. I got angle B is what we just did, Jeff. So now I can figure out what angle C is, add these together. And the one thing you gotta be careful about is if this was a reference angle, it would be about 140. Does everybody see what I'm saying? That's roughly 40. So that'd be about 140 would be what this is a reference angle for. And that's possible in it. Well, that sucks. See, that's why I don't like using law of sines. Now I'm curious. Everybody hold on to that. Everybody hold on. This is the answer that makes sense because it's a little bit bigger than A. So I'm pretty sure the other one can't make any sense. Yeah, so then angle C would be, what do you get there? 76, so 103.52, maybe?
I got 107.
Oh, so it's probably just me. Let me see, 40. Why did I do 76? That's what I did. 73, so 72. Yeah, 107. Okay, thank you. Not a good night for Jeff's mental math. But you see, whenever you use sine, you are going to have to worry about the possibility that your answer is a reference angle. If you just use law of cosines, the inverse cosine will give you the exact answer because its answers live between 0 and pi. It's not going to be a reference angle for anything that's possible in a triangle. I don't know if you guys are with me on that. That's why inverse cosine, I love this. Cosine's an asshole. Inverse cosine is fantastic because he's cosine's inverse. It makes sense. Okay. Maybe. So that was a great observation somebody made. A problem could start off as law of cosines, and then you can use law of sines, or it could start off as law of sines, and then you can use law of cosines. That's always a possibility, but there is that built-in problem with inverse sine that I remember as a student kind of avoiding it if I could. Okay, all right. Let me see. That's all I wanted to do with those. I did want to talk a little bit about, we're about to get into. Yeah, let me, all right, I want to talk a little bit about this. So let me pull this up. All right. And then we'll head out. We'll head out right after I finish talking about this one thing. And I know I've probably said that before and not held up to it. So take that with a grain of salt. Where'd I put you? Here you are. I don't like that one as much. Let me use this one. Yeah, this one looks cool. All right, give me a moment, everybody. This is gonna work. You gotta do it. There it is. All right, kick ass. Where'd you guys go? There you are. All right, let me move this over here. All right, so let me show you this. This is where we're about to get into. Where did you go? Oh, there you are. Okay. Don't pay too much attention up here. We got shit to do for this, but I want to show you this. Doesn't that look exciting? Actually, I'll tell you what. So we'll come right back to that in a minute. If I wanted to tell somebody how to get to a certain place, one way to do it is to do it the Cartesian way. Good old Descartes. Descartes was like Utah's God, because Utah is on this complete grid, you know, so it's just an XY plane. It's insane. So one way to tell somebody how to get to a certain point is to say, okay, wherever you are, go this much over and this much up, right? You guys, everybody with me? That's the XY plane. Whoop-de-doo. What's another way to tell somebody how to get to that same point is to say, all right, turn by this much, turn by this angle, and then walk this much. So I could say, so either I could say, go X over and Y up, and that's the Cartesian coordinate way of doing it. That's the location of something. Here I am at my house, and there's the bank. Or you could tell me, all right, you're facing that way, turn this angle, and walk this far. So that would be r theta. I really want you guys to get that. So there are multiple ways to tell someone how to move on a plane. One way is very rectangular. I don't know if you guys understand. XY coordinate system is very, very rectangular. There are certain math problems that don't work well with rectangles. I don't know, for example, a circle, right? So why don't we make the most basic way that we interact with the equations is to graph them. Why don't we create a graphical method that's circular, not rectangular? So that the coordinates I would use would be the angle I turn through and the distance I walk. Angle, distance. So if somebody wanted to go here, I would turn through a greater angle and I would walk a shorter distance. Right, so let me come back to this. That's the idea behind this. So if that little fly that was on the ceiling above Descartes, according to urban legend, I don't know if you guys remember this. I'm pretty sure I told you a story where it's walking in circles. Maybe he would have developed this first, which is called a polar graph, not a polar express. I'm sorry. It's a polar graph. There's a pole right there. So last thing, if I wanted to graph the point 3 pi over 3, just like on the XY plane, we start at the origin. So what does this tell me to do? Turn to pi over 3, so face pi over 3, and then walk 1, 2, 3 out. So the point is right there. What do you guys think about that? I mean, that's pretty basic. You know it's going to get much more interesting. And in fact, just to give you a little preview, here are some basic graphs of polar equations. You got cardioids, otherwise known as the butt graph affectionately. You got the leaves. That is, you see how there's a 3 there and there's 3 leaves? But if there was a 4 there, there wouldn't be 4 leaves. Oh, and we're going to talk about spiral of Archimedes. Just stare at that and become under my spell. I can't remember. I think it's Limousin. I got to look that back up to see. And then there's a ton more than this. Than the ovals of Cassini. I just put that on there because it sounds so freaking cool. And it looks like a freaking peanut. All right. This is so cool. And to me, did any of you guys ever have a spirograph game? With the gears, you could put your pencil in. I mean, this is before, before we had them Xboxes and the switches. We have these little gears and we pretend like that was fun. But no, it was fun. These are awesome. These are basically graphs you could make with those gears. I want to remind you also, remember that butterfly that's up on my Canvas page? We will learn the form. You're not going to memorize it. I'm going to show you. Let me say it like that. I will show you the formula that you can plug in your calculator to create a butterfly. All right. All right. I don't know what else you want from me. I mean, my God. All right. That's enough. That's enough. I need to check on things and brood and drink the rest of the night. So I should be recovered by the time it's time for your class tomorrow. My earlier classes, we'll see what's up. All right, so let me know if you need to hang out. Otherwise, you are free to go. I have not posted that sheet I just showed you yet. You got enough to worry about already. Anybody, if you don't need to hang out, that's fine. Let me know if you do.
Thank you.
Thank you.
You're welcome. All right, I'm out of here. See you guys.